Okay, girls, exercise 3.10, homework problems, question 5. The first question is question 5. Use the substitution u squared equals x plus 2 to find the square root, integral of x minus 2 over the square root of x plus 2 dx. Okay, we can see that we can do the substitution for the x plus 2 we've got over u squared, okay? Remember, we don't do, I need a substitution for x minus 2. Now what you can do, I'm going to start off with this u squared equals x plus 2. What? Yes, let's make x the subject. X is u squared minus 2. So girls, tell me what x minus 2 is. So over here I'm going to write that x minus 2 would be u squared minus 2 minus 2. I'm just adding. If x is u squared minus 2, the reason I'm looking for an expression for x minus 2 is I need it on the top. So if I just go take away 2 from both sides, I've got x. If I take away 2 here, I take away 2 there. Does that make sense? So therefore, x minus 2 is u squared what? Minus 4. Or you could just put in that the x is u squared minus 2 here, and you still got another minus 2. And you'll get u squared minus 4 there anyway. So you can do it either way. What should I do over here? dx du is 2x, 2u. Okay. So therefore dx is 2u du. Okay, girls, I believe I can substitute now. We've got a substitution for the x minus 2 here. We've got a substitution for x plus 2, which is there. And we've got a substitution for dx, which is there. Okay? All right. Is this what you're confused about here? What you could do, girls, is just substitute this x for u squared minus 2 in here, and then you still got another minus 2. Do you get that? Is this what you're confused with? Yes or no? You're trying to, we know that x is u squared minus 2. So x minus 2 would be u squared minus 2 minus 2. I'm just subtracting 2 from both sides. Or I can just put the u squared minus 2 here, and I've got minus 2. So if you don't want like this, I won't do this bit down here. Do you want me to cross that out? All right, so let's do our substitution. X minus 2 over the square root of x plus 2 dx is the same as the integral of, what do you got? X minus 2, I could have just gone that x is u squared minus 2 and then put another minus 2, and I will get u squared minus 4 over the square root of, x plus 2 is u squared, and dx, wait a sec, let me just do it all, it is just u. Why is it so confusing? What does x, can you see an x plus 2 anywhere up here? An x plus 2. Can you see something that says x plus 2? What does x plus 2 equal? So you replace the x plus 2 with a u squared. All right, what does dx equal? 2u du. Integral of u squared minus 4 times 2u du over u. What can you cancel? The u and the u. So isn't this integral of 2 lots of u squared minus 4 du? You can take the 2 out, or you can integrate, or you can just integrate 2u squared minus 8. You can do that as well. Okay, which is? So it's 2u cubed over 3 minus 8u plus c. And now just replace u with what? U squared with what it is. Okay, so you've got 2 over 3. Isn't it? I only know what u squared is. So if I do u squared and times it by 3 on 2, like take it to the power of 3 on 2. Girls? Does that work? What's 2 times 3 on 2? U3. The other thing you can do, girls, you don't have to do it like that, if that's confusing you. One sec. Oh, I don't have it. You can just write out, I know that u squared is x plus 2, so u is the square root of x plus 2. Why don't you just substitute that in? It's probably easier, actually. So I'm going to get rid of that. So I'm just going to write it as equals 2/3. What does u equal? It's probably better like this, girls. Square root of x plus 2 cubed. Got it? Minus 8. This is actually a lot better. Root x plus 2 plus c. And you're done. Use the substitution u equals 2x minus 5 to find the integral of x over the square root of 2x minus 5 dx. Okay. Just tell me something I can do. You can make x the subject, but I don't think I'd do dx du, all right? You know, because it's not u squared, let's start off with just, we know what u is. Do I have a substitution for this 2x minus 5? All right, that's good. I need to find a substitution for x and dx, but let's see, let me just do du dx and let's see what we get. What does du dx equal? 2. All right. So I would make it as dx. I'd make dx the subject, and what's that equal to? Du over 2. So far, this is what we've got. So du dx is 2. I'm not going to make du the subject. Like, I don't have a 2 dx to substitute. Dx, I'm going to swap these two, is du on 2. So I've got a substitution for the dx, that's done. I've got a substitution for the 2x minus 5, that's done. I need a substitution for the x now. So start off again with u is 2x minus 5. Now what would you do? I just want to make x the subject. U plus 5 is 2x. So x is u plus 5 over 2. All right, let's substitute. The integral of x over root 2x minus 5 dx is... It's okay. All right, what does x equal? U plus 5 over 2. Girls, when you've got fraction on fraction, you know that bottom fraction? It goes next to it. It stays on the bottom. Okay? So just, if I do, just watch. I think you need to learn that trick, girls. Let's say I'm doing, just down here, if you can see, what's a half divided by 3? See how I've got that? A half divided by 3. A half divided by 3 is a half times a third. So next time you do a half divided by 3, it would be just better to do a half and put the 3 next to it. You got your fraction, whatever's at the bottom of the fraction stays with that 2 at the bottom. Okay? A half divided by 3. So for example, is 1/6. So coming back here, you've got u plus 5 on 2 over this. That just stays on the denominator. That u. That's it. All right? Because it's that over that, that bit goes down next to that. Got it? I think it's a good trick. You need to learn that. All right? And what's dx equal to? Times du on 2. Now, what can I do? The 2's are 4, that's good. U plus 5 over 4 root u du. Girls, we do not integrate quotient rules. So I don't want to see, we don't do that. All right, so how can I break this up? Well, isn't it u over 4 root u? Aren't they both over the same denominator? Plus 5 over 4 root u? That's what you do. You break them up. No, because it's got to be associated with 2 things. Yeah, okay. You can. But I think to make sure that people do that, they're both over 4 root u. Just let's play the safe way. You can take out the quarter, but then you've got to bring it back in later, so I'd just leave it there. What do we got? What's u on root u? Girls, u is root u squared. So where are you going to have what? Root u on 4. Girls, u is root u squared. So you get root u on 4. Girls, we've done that before. Plus, now 5 on 4. I don't want that root u on the bottom. U to the negative a half. And this one really is u to the positive a half, isn't it? So I might just fix that. U to the positive a half. Oh, anyone got a tapey thing, please? I can see. So you can either do it. Instead of writing root u to save me a line of working, I've done u to the half. So I can integrate it. I had root u there. I can't integrate when it's root u. Sorry, what have I done? U over root u is u to the half on top. No? U to the 1 divided by u to the half. You know how, were you okay with root u at the top? Root u is u to the half. Alright, so what have I got? U to the over 3 on 2 times 4 plus 5u to the over a half times 4 plus c. Girls, so what have you got? U to the 3 on 2. How do you rewrite that?
It's square root of u. Yeah. Yes.
Over. What's 3 over 2 times 4?
It's 6. Because the 2 cancels.
Or it's 12 on 2 plus 5 over half of 4. All right, and then you just replace the u with whatever it is. And u is 2x minus 5. Put it in brackets. Yep.
We would end it there, right? Like,
Where?
we would end it there, right? It was like minus 5 to 5.
Why? The negative a half. Question 12 from exercise 3.10. A curve has dy dx equal to x over the square root of x plus 1, and it has a y-intercept of 2. By them telling you it's got y-intercept of 2, it's giving you a point on the original curve. Does that make sense? So they're saying find the domain. What's that got to do with? The x values that are allowed. And what does that depend on? The denominator. So what do you think that denominator, tell me about, so the denominator, yeah, but tell me something about that x plus 1. It has to be?
Positive.
It's got to be positive. Can it equal 0? Because? Good. So, and it's got to be positive because you have to have, you can't square root a negative number. So x plus 1 has to be greater than 0. Therefore, x is greater than negative 1. That's your domain. Okay, so x is greater than negative 1 is your domain. Part B. Evaluate y when x is 3. Before you can evaluate y when x is 3, you need to come up with the equation for y. Yes. So you know what dy dx is. So therefore, y is the integral of the dy dx. Integral of this. Do you get this or not, girls?
Yes.
If that's the first derivative, then to get to the original function, it's you integrate the derivative to get to the original function. All right, girls, you're going to have to do integration by substitution, obviously. So what do you think you'll let u equal x plus 1. So therefore du dx is?
Did you just make that up?
Yes, I did. What else could you use for a substitution?
I was just asking for
No. Yeah, normally they're supposed to, but obviously in this case they're not giving it to you.
But they will give it to us.
They should. Well, I'm just a bit worried now. They may not. But in a case like this, you would just let it be whatever's under that square root, all right? So let u be x plus 1. So du dx is 1, which means that du equals dx. Good. Remember, we're trying to integrate that. Now, I have a substitution for the x plus 1. That's good. I need a substitution for x. U is x plus 1. Therefore, x is u minus 1. And we're all done. So therefore, the integral of x over root x plus 1 dx. Do you notice what we're doing? We're trying to come up and replace each of these. X equals u minus 1. X square root of dx equals. Before I integrate this, we do not integrate. You separate them. Each of these terms on the numerator is over root u, so it's u over root u minus 1 over root u. Now, u to the half minus u to the negative a half du. Girls, u on root u is root u on top. U is root u times root u. All right, what do you get? U to the 3 on 2 over 3 on 2 minus u to the half over a half plus c, which is, what do you do now? 2/3. Yep.
See how before you started integrating, if they're the same base, can't you just add things in?
But they're not the same.
It's you.
All right, now what have we got? U cubed minus 2 square root of u plus c, and then sub in the x's. 2/3 square root of x plus 1 cubed minus 2 times the square root of plus c. No? Now, oh, we're not finished. We need to work out what c is. Well, c is 2 because the y-intercept equals 2. So you can sub, y-intercept is the point 0.02, sub x is 0, y equals 2 to find c. So you get y equals, actually girls, it's not 2. It's not, because have a look. Don't ever make that, have a look. So y-intercept is 2, which means 0, 2. Sub x is 0, y equals 2 into this equation above, and have a look. So isn't it 0 plus 1, which is 1 cubed, minus 2 times the square root of 0 plus 1 is 1, plus c. Be very careful. And what's y? What do I substitute for y? 2. Sub x is 0, y equals 2 into this equation here. And you get 2/3 minus 2 plus c. And what do you get? C is, girls, you're given a point, you've got the equation of the line. The problem is you need to find c. The way we find c is to substitute a known x and y value into the equation to find c. Now, don't just assume that it's going to be 2, because unless you were substituting a straight x. If you were substituting into a straight root x, it would be, but we're not. So be very careful. So what do we get? C is 3 1/3, which is 10 over 3. So therefore your equation is y equals 2/3 times the square root of x plus 1 cubed minus 2 times the square root of x plus 1 plus 10 on 3. That's your equation. Now you find when x equals 3, what does y equal? 2/3 square root of 4 cubed minus 2 times the square root of 4 plus 10 on 3. What's the square root of, I did the square root of 4 first. So 2/3 times 8, which is 16 on 3, minus 4 plus 10 on 3. You can write 4 as 12 on 3. So I'm going to go common denominator and do it in my head. It's 16 minus 12 plus 10 all over 3. Are you okay with that, girls? 4 is 12 on 3, and that's 14 on 3. Don't need a calculator, which is 4 2/3. So, doing questions 9, 10 and 11 for homework. Now notice they're not, if you've got dy dx and you want to find the equation y, you have to, Gloria, good. And what do you think you might let the substitution for the first one be? Just, yeah, let u be x squared minus 1. Good. What about question 10? What do you think you'll let u equal? Actually, girls, wait a sec. Stop. Have another way. Girls, can everyone please look? Look at question 10. Instead of doing integration by substitution, what can you just do? Minus x, yeah, just expand it and do that one. You don't need to use. Girls, because that's all just simple. That's 3x cubed minus x. So just expand it and then integrate it. Got it? Yeah, no. I've got 3x cubed minus x. Yeah, you would expand it before you integrate. Do you get it? You do not... For question 10, I would just expand before I do the integration because there's no square roots anywhere. There's no squared or cubed functions. It's just like that question in the exam asking you to, if there are no square roots or cubes or to the power of 4s or 5s or squareds,